Hey guys, just wanted to do one more of these videos where we talk about induction charging. So let's go sort of to the Latin behind conduction, which the previous one was on, and induction. Con in Latin, same as Spanish, means with. Induction means passage, but let's think about it as like flow. That's sort of how it can be described as well. So in conduction, there's flow between the charged object that you start with and the object that you then begin charging. So if you touch a charge rod to a sphere, charge will flow between the rod and the sphere. So with flow. Induction then means without flow. So you can charge something without it even flowing between two objects. So let's show that in this little animation right here. So it's going to restart here in just a second. So here comes a negatively charged rod. When it's near this metal sphere, it will polarize the sphere. The charges will separate and you'll get a negative charge. Here comes a hand to touch it. That will push the electrons actually into the hand and down to the ground. Since you've pushed electrons out of the sphere, you have left the sphere with a positive charge. So you started with a negative rod and you pushed the electrons out and made it a positively charged rod. Let's see that one more time before we move on here. Negatively rod comes down, polarizes the sphere, but doesn't charge it yet. It's not until you ground it, until you touch it, that you are able to push the electrons out of the sphere and into the hand there. So let's look at a second example here. Here we have two metal spheres in contact with each other, and a negatively charged balloon polarizes both of them, pushes the electrons to the right sphere. Then if we separate them, those electrons won't be able to get back. So there's a negative charge stuck on the right one, and therefore a positive charge stuck on the left one. We use the negatively charged balloons to push the electrons into the second sphere. So again, negatively charged balloon polarizes the group of them. Electrons move to the right sphere from the left sphere. So here we move them back, and the right sphere is now negative, leaving the left sphere positive there. Notice both in this case and the previous case, nothing flowed between the charged rod in this case and the balloon in this case here. Okay, now one more example here. Here's a negatively charged plate. We bring a metal pi plate down near it. We polarize the pi plate. We push the electrons to the top, but it's not charged yet. Not till you touch it and give a path for the electrons to be pushed out of it. Now let's do one more example here. So here we have a neutral electroscope, piece of metal. We have a negatively charged balloon, pushes the electrons down. And if you touch it, you could push the electrons out of there and leave the electroscope positive in that case. So there's a couple of examples. In this case, in this case, in this case here, we all start with a negatively charged balloon, and this one as well. So we really need an example as well. What if you had a positively charged rod in this case? Then when you touched it, you would actually pull electrons into the sphere, making the sphere negative. So again, if the rod was charged positively, when you brought it near the sphere, it would polarize. But then when you touched it, so let's sort of imagine this and talk on top of it. I don't have an animation of this, but let's say that this one is positive. There'd be negative charges on the left, the rod being positive, and positive charges on the right. And when you came up and touched it this time, electrons would be flowing into the sphere, making the sphere overall negative in that case. So it would be the exact reverse of the way it's animated here. But keep in mind, just like everything that we've done so far, the only type of charge that can ever move are the negative charges, never the positive charges moving.